Welcome one and all to the second video among the series of videos on blockchain. In this video, we will be deep diving into the real life manifestation of blockchain, the two success stories of blockchain, that is Bitcoin and Ethereum. Understanding their implementation will give you further insight into the power of this technology and why it will act as a catalyst for the start of fourth industrial revolution. I have given this session quite a millennial name, BaE of Blockchain, that is Bitcoin and Ethereum of blockchain. So let's get started. So blockchain and me. So I am Jitin Fernandez. I have 12 years of experience in IT industry. I'm a PMP certified IT project manager based out of Dubai. I'm blockchain certified and take a lot of interest in this technology. The previous session I gave was a blockchain introduction. I would request you to go ahead and see that first if you have not already seen it, because that will lay the foundation of blockchain. It will explain how the technology works, and seeing that video first will help you understand this better. So let's move on. Also, what I will do is I will quickly give you the basic fundamentals of blockchain. We will just quickly go through it. So blockchain is completely decentralized. There is not a single authority which decides who will be part of blockchain, what are the rules and regulations. No, completely decentralized technology. It is distributed. Every node in the blockchain world will have a copy of blockchain, so it is very difficult for the hackers to hack and alter the transactions. So it is immutable as well. The transactions which happen in the blockchain world are transparent, meaning anybody and everybody can go ahead and view what transactions are happening in the blockchain world. At the same time, it's anonymous. So if you see, there are completely opposite views. At one end we are saying it's transparent, the other end we are saying the transactions are anonymous. You will understand this when you go through this course, how both the fundamentals marry each other in blockchain world. Moving on. I've put up a slide, Genesis to now, to give you what the journey of Bitcoin is from the inception to now. This technology was born when Satoshi Nakamoto published a white paper in 2008 where he gave the details about the technology and how this can be implemented for using Bitcoin as a cryptocurrency. In Jan 2009, the first Bitcoin was mined and it was below $0.01. And after that, you can see there was a steady growth. In 2013, one Bitcoin crossed $1,000 mark for the first time. There were illicit activities using Bitcoin, which ended up crashing the Bitcoin currency. The Bitcoin was used for drugs and other criminal activities. But after gaining more confidence, it started to rally up from 2050 to 750 mark between 2015 and 2016. In 2017, it surged to its peak of $19,783.2. Now, if you go ahead and see, Bitcoin would be rallying around 7,000, 8,000. So in the journey, there has been a lot of ups and downs. Any new technology, when it comes, it takes time to settle and become mainstream. So I suspect that going ahead also there would be fluctuations until Bitcoin becomes stable. Let's move on. In this slide, we will talk about few concepts which is necessary to understand Bitcoin. I will explain these concepts using an example. For this, I would need an Excel. Consider Chandler wants to send money to Joey using phone banking. Okay, so this is Chandler, Joey. Okay, and suppose he is planning to send $100. So for phone banking, if a Chandler wants to send money to Joey, Chandler should have his account number. Suppose his account number is 123, and Chandler should know Joey's account number, which is 456. Chandler should be aware of his password. Suppose Chandler's password is ABC. Chandler will initiate a transaction, and in phone banking, if you have to transact $100, you should have 100 or more dollars in your account. So Chandler goes ahead and initiates a transaction, and whenever you initiate a transaction, you go ahead and use your private password. So in a way, using your password, you're authorizing that I agree that I am paying $1,000 to Joey. So the moment the transaction is initiated, it goes through the banking system, and Joey gets an intimation that he has received a $100 credit. Now for Joey to spend this money, Joey should be aware of his banking password. Unless he is not aware of banking password, he will not be able to use this $100. Okay. Bitcoin also works in much similar way, but there is a concept of public key and private key. We will go ahead and generate public key and private key in through this website. This is bitaddress.org. So as you can see, I'm moving my mouse around the web page, and the percentage is increasing. The moment it reaches 100%, it will give us our identity in Bitcoin world. So here you go. So you can see there are two keys which are generated, share and secret. Share is nothing but the public key. So I'll just copy that. And secret is nothing but the password as a private key. Likewise, I didn't copy it properly. Okay. Likewise, I'm just typing here. Joey will also have a public key, and he will have a long string, which is the private key. And the deal with the public key and private key is this combination is unique, and there will be only one such combination in the Bitcoin world. And using the private key, you can generate the public key, but using the public key, you can't generate the private key. It is very much synonymous to the phone banking system. Everybody can be aware of the public key. Everybody can be aware of the account number, but using the account number, you can't decode the password. Likewise, in this world also, using the public key, you will not be able to decode the private key. In Bitcoin world, if Chandler has to send Bitcoin to Joey, in that case, Chandler has to initiate a transaction with Joey's public key, and at the same time, he will have to digitally sign the transaction using his private key. So Chandler goes ahead, says, I have to send 1 Bitcoin to Joey's public address, and he digitally signs using his private key and initiates a transaction. As soon as he initiates a transaction, one of the miners will go ahead and pick it up. So let's imagine that Ross is a miner. He goes ahead and picks it up. Since the public key is accessible to all, Ross will be able to view the transaction details and he can see that Chandler has digitally signed, meaning Chandler has enough credit and validates that he wants to send 1 Bitcoin to Joey. He verifies the transaction and adds it to the block. The moment it is added to the block, then it cannot be muted. So when it traverses through the network and it reaches Joey, Joey finds out that he has got 1 Bitcoin credit. Now for Joey to spend this Bitcoin, Joey will have to use his private key. And since Joey only has the private key for the corresponding public key, he's the person who can only spend this, nobody else. So this is how the transaction works in Bitcoin using public key and private key. Okay, let's move to the next concept. Now the next one is wallet. As you can see, these keys are very complicated to memorize. In our phone banking application, our passwords may be 6 to 10 characters, and that too, we are authorized to select our own passwords, which are easy for us to remember, which we can relate to. But these random string of alphanumeric characters is very difficult to remember. So we have a concept of wallets. So wallets, what they do is they hide the complexities behind the system, and it makes the application as easy as it is with phone bank. So this one is Jack's wallet, where you can see you can transact Bitcoin, Ethereum, Bitcoin Cash, and many cryptocurrencies. In this, you can go ahead and configure your private keys and public keys as well. So for each one of them, I have gone ahead and configured my public key and private key. And as you can see here, this is my public key, which I can share it with all, which will help miners to validate my transaction as well as others to send money to my account. And this is the private key, which I will keep it with me and won't share. Whoever has this combination will be able to spend the Bitcoins in my account. So the private key should be kept totally safe. Okay, I'm just going back. So if you see here, you have normal options like send, receive, like we have in a phone banking application. And here you can put the public address, like if you want to send money to Joey, I will just copy his public address. Now this is not a valid address as I put a random key, and I will mention the amount. Okay, and then I will click on send. You can see that message came up that it's an invalid public address. Okay, so this is how the complexities are hidden inside using the wallet, and this is how you can keep your public key and private key in the wallet and use them to send and receive Bitcoins. Moving to the next concept. Okay, now consensus and block creation. We did brief about this in the first session, but we didn't go deep dive into the consensus algorithms. So there are a lot of consensus algorithms like proof of work, proof of stake. So the one which is used in Bitcoin is proof of work. Each miner in the Bitcoin ecosystem wins 12.5 Bitcoin if they successfully mine a block. And to successfully mine a block, the Bitcoin ecosystem gives them a puzzle to solve. So all the miners in the ecosystem are competing against each other to solve this puzzle. And this puzzle needs a lot of computational power, and it will cost hundreds and millions of dollars, as well as a lot of energy consumption. So there are two activities which a miner does. One is validate all the uncommitted transactions. So whatever uncommitted transaction they can find in the system, they collect and validate them. Once that is over, which is a very easy job to do, they have to solve the puzzle, and whoever solves the puzzle first is considered as a winner. He gets the authority to create the block, and once he creates the block, he goes ahead and propagate it to the Bitcoin world. and once it is unanimously agreed, the block gets committed and added to the blockchain. Now what miner gets is 12.5 bitcoins for solving the puzzle and creating the block. In present world, one bitcoin is around $8,000, so you can imagine, right? It's a pretty good money. So that's how proof of work helps in creating consensus in Bitcoin world. Moving on. Okay, I will take you through the Bitcoin transaction to give you a real picture of what is happening in the live Bitcoin world. Let's go there. So this is the link I have already opened and kept. So this is a blockchain explorer. Here you can go ahead and view transactions real time, which is happening in Bitcoin, Ethereum, and Bitcoin Cash world. Currently you can see the price is for one Bitcoin is around $8,721.65, and these are all the transactions which happened today. I will launch one of them. This is a block which was created, and this number is same as the height number. This says that this is the position at which the block is. It started from the Genesis block, which is block 0, and currently we are at 580924th block. Okay, and there are 2917 transactions in this block, and they have given the total output of this, how many bitcoins were mined in this block, the timestamp, the transaction fees. The difficulty determines the difficulty of the puzzle to earn 12.5 bitcoins. Okay, the size, the weight, the version, all these are self-explanatory. Nonce is actually the number for which all the miners are solving the puzzle for. Everyone is behind this number. Also, as I had explained in the first session, every block will have the hash of the previous block, which is here. Once it's a complete blockchain, you will have the hash of the next block also. I will explain what is Merkle root and hash. Before that, let's go ahead and see few transactions. These are the transactions which have been committed in this block. So this is the sender public address, and this is the receiver public address, and you can see how much bitcoins has been transacted in this transaction. Also, if you see a random number above, this is nothing but the hash of the transaction. So the moment a transaction is initiated from sender to a receiver, it creates the hash of the transaction. The reason why it is done is you can't alter anything after that. So every transaction, as you can see, has a hash associated with it. Merkle root is the root hash, which is derived by hashing all the transactions. So it is the parent hash, which is combination of all hashes of the transactions which reside in this block. So what happens is, if you go ahead and change anything in the transaction, the hash of the transaction changes. If the hash of the transaction changes, the hash of the Merkle root changes. So that's how every transaction is secured and made tamper resistant. Likewise, you see one more hash here. This hash is arrived by hashing Merkle root as well as other header properties. Now you can imagine how robust this technology is. At the same time, how transparent this technology is. Every transaction can be viewed and checked upon. Also remember, I had told that the transactions are transparent yet anonymous. The reason why I'm saying this is, here we don't mention, for example, Chandler is sending money to Joey. Here we mention this particular public address is sending money to this public address. The person resides behind this public address, and it is very difficult in real life to understand who owns this public address. So even though the transactions are transparent, yet the transactions are anonymous. I hope you are able to join the dots completely and understand the Bitcoin better using this example. Anytime you want to go ahead and see, just go to blockchain.com and select Bitcoin and go ahead and click on one of the transactions. Okay, let's move on. Now, I have been talking about all the great thing Bitcoin does, but there's a flip side to it. These are the challenges which Bitcoin is facing right now. The first issue is scalability. Bitcoin on an average can process only 7 transactions per second, while Visa can process around 1700 transactions per second, and MasterCard can process around 5000 transactions per second. So if you compare it with Visa and MasterCard, the performance or the scalability is a big problem in Bitcoin world. It is expensive. It is very expensive. The amount of energy needed to sustain a blockchain for a year is equivalent to the energy consumption of various countries. It is said that last year in 2018, the energy consumption of all cryptocurrencies was more than energy consumption of 128 countries. In this world, where we are finding it difficult to sustain and we are looking for alternatives of clean energy, spending so much electricity on Bitcoin is not sustainable. And Bitcoin extension is a problem in the sense you can use Bitcoin clearly for transferring Bitcoin. You can't add some intelligence there to make it act differently. That is not possible in Bitcoin world. And as you saw, the Bitcoin currency keeps fluctuating. It started from 0.01 dollar. It reached till 19,000 plus dollars for one Bitcoin. And now when we saw, it was around $8,700. So it is very volatile. It will take a while to stabilize. The vision of Bitcoin is one cryptocurrency throughout the world. Acceptance is a problem. Not all governments will agree to it because they will end up losing control. Since Bitcoin is completely anonymous and we will not understand who is transacting money to whom, even though we can see it, and for what purpose, this technology can be used for illicit activities which are not legal in this world. So these are the challenges which Bitcoin faces. Let's move to Ethereum. I would like to term Ethereum as an evolved Bitcoin, and I'll tell you why. So the first point is, with Ethereum, the processing has not outdone Bitcoin but has improved compared to Bitcoin. It is able to handle 15 transactions per second instead of 7 in Bitcoin. The block creation time is 15 against 10 minutes in Bitcoin. Ethereum concept works like bank account unlike Bitcoin. Okay, this I would like to explain you with an example. I'll open a new sheet. So in Bitcoin, when Chandler sends money to Joey, what happens is, if Chandler has $200 and he wants to send $100 to Joey, what happens is he has to spend it all, in the sense he will have to have one transaction where he sends $100 to Chandler. At the same time, he would have to initiate another transaction to himself. So there is no balance keeping like it happens in the real world. So that's how it works in Bitcoin world. While in Ethereum world, how it happens is when you have to send $100, it will check whether it has $100 and transact only that $100, and the balance remains in your account like it happens in traditional banking. Okay, so that's what it meant by Ethereum state concept works like bank accounts, unlike Bitcoin. Now, we did discuss about proof of work as a consensus algorithm. Ethereum is proposing new consensus mechanism which is called as proof of stake. So why it is different and why it is efficient, let's take it through an example. So suppose there are multiple miners in the system. In Bitcoin, every miner in the ecosystem is trying to solve a puzzle which is highly energy expensive and it needs a lot of computational power. In Ethereum, it proposes each selected miner rather, to bet, in the sense miner 1 will say, okay, I'm betting 100. Miner 2 may say, I'm betting 101. And miner 3 will say, I'm betting 105. So whichever miner bets with a higher amount essentially gets the ownership of creating a block. Now, since his amount is kept until the block is created, he is in a way betting and that particular amount is locked. So whoever is proposing higher amounts will not go ahead and rig the transaction, because if at all he tries to rig the transaction, he has kept a deposit and that deposit will be taken up by the Ethereum world. In this way, what happens is each miner is made accountable. So with this, what happens is, first of all, you are not spending lots of energy, lot of computational power to solve a puzzle. At the same time, since you are finding the highest bidder and keeping that money as deposit, the miner who is bidding will ensure that all the transactions in the block are correct, are verified, and there is no way he would keep so much money in stake to initiate a wrong transaction. So this particular proof of stake concept is being currently built. We will have to see whether it gets widely accepted in the Ethereum world. But this is what is proposed for Ethereum to handle the computational expense of proof of work consensus algorithm. Now in Bitcoin, I did tell you, right, that you can use Bitcoin only for transaction of Bitcoins. You can't use it for any other purpose. You can't have a logic built in. But in Ethereum world, there is a concept of smart contract. With smart contract, you will be able to code logic into Ethereum world. Let's see how. I will take you through few actors which will help you to understand what we can achieve using smart contract. The first one is Solidity. So Solidity is the language which is used to write smart contract, and remaining concepts I'll explain through an example. Suppose you have taken a loan from a bank and you have to pay bank $100 monthly. Now using Solidity, you code in the Ethereum world. So we say that on 5th of every month at 12 a.m. initiate a transaction where you deduct $100 from Ross's account and credit that $100 to the bank account, to a specific bank account which is owned by the bank which gave money to Ross. So using this mechanism, you are completely coding a blockchain where the sender would be Ross's public address, and at the same time the smart contract will have a public address which will go ahead and invoke the transaction, and when the transaction is invoked, it will send money to the bank public address. So all this monthly deduction will reside in the Ethereum world, and it will be completely automated and triggered. And since everything is occurring in the Ethereum world, at any point of time you can go ahead and see what all transactions has happened, and you can see whether the money has credited the bank account. It's completely transparent. This is one of the example how putting a logic in Solidity language will help to evolve blockchain applications to handle such scenarios. Now, since Ethereum gives you a flexibility of running smart contracts, I will take you through a concept of gas price and gas limit. Okay, now certain smart contracts will be very simple, like adding two numbers, while certain contracts might be very complex. So it won't be fair enough to charge a standard price. So every smart contract, depending on the amount of function used, will need a certain amount of gas. Gas is nothing but the fuel to run. Suppose to run this auto deduction of EMI, the gas is coming to 0.5. Now, this is the gas price set for this transaction to run. So if you want this transaction to run on higher priority, it is up to you to give an amount which is more than the gas price. So if suppose we are saying we will pay 0.7 for running this smart contract. Now what it does is, higher the gas price you are bidding for this particular smart contract to run, this will attract the miners, because whatever gas price you are paying, essentially whichever miner mines this transaction and adds it to the block, he will earn this. So putting a higher amount than the needed gas will put you in front. So this is how you skip the line in Ethereum world. Now, to keep an upper limit, there is a concept of gas limit. So if we put here 1, so it says that if you want to run the contract, you are allowed only to give a gas price up to 1 Ethereum, not more than that. This is how these terms come to picture in the Ethereum world. And this is how Ethereum world operates, using these concepts to help Ethereum to be more than just a cryptocurrency. Here now you can put logic and you can run any sort of application in the blockchain world. Now, since you are writing logic in the Ethereum world using Solidity, there should be a compiler who should be able to understand these instructions. So the Solidity code for a smart contract is converted to bytecode, and it is given to EVM, and this EVM then executes the smart contract. So this is the compiler who goes ahead and executes the smart contracts in the Ethereum world. So to put everything together, you can go ahead and write any and type of smart contract. You can code in logic in Ethereum world. Each smart contract comes with a gas amount. You can go ahead and quote your amount more than the gas amount so that you can jump the line. But at the same time, Ethereum world has kept the upper limit. You can't quote a price more than that. Let's move on. So, like we explored Bitcoin, let's go ahead and explore Ethereum and smart contract. So I'll go back to the browser. First, we will go in blockchain.com itself. And as you can see, the second tab is Ethereum. Let's go ahead and click that. Currently, Ethereum is at $272.28. We will go ahead and quickly open one transaction. It's the same. Each block will have an hash, and it will be unique, and the hash will be combination of all transactions. Okay, and this is the difficulty like we had in Bitcoin world. This is the gas limit. This is the gas used. This nonce has a similar concept as in Bitcoin. This is the puzzle everyone is mining to. As I said, we are trying to move from proof of work to proof of stake in Ethereum, but we are not there yet. So the algorithm is similar until now in the Ethereum world. This is the reward earned by the miner for executing this block. And these are the transactions. These are the transaction hash. Go ahead and see in this transaction. You can see from whom the transaction has initiated, and it has gone to this particular account. And you can see the gas price, gas limit, gas used for this transaction. Okay. So this is how transactions happen in Ethereum world, very much similar to Bitcoin. But let's go ahead and see a smart contract. So I am in etherscan.io, and if you go under blockchain menu, you can see verified contracts. I will select one of the contracts. Come here, see, this is a logic written here. So as soon as you go ahead and execute a smart contract in Ethereum world, it has to be verified. Once it is verified, it will have a contract public ID, and anyone who wants to execute the smart contract should communicate to this public address, and this is the code which will get executed when you run this contract. So yeah, so all the contracts seen and verified and browsed in ethereumscan.io. Learning Solidity and learning how to build a smart contract will need altogether a different session. With Ethereum, you will be able to build logic. That means you can go ahead and write any type of dynamic transactions and put it in blockchain world, and which can be triggered from an outside world. Like if you want to transfer a property, you can initiate a transaction which will go ahead and execute a smart contract for property transfer, and the property transfer can happen Ethereum world. So that's the power that comes with smart contracts in the blockchain world. Moving on. So yeah, we have reached the end of this session. I will just summarize with these points. So if you see, with Ethereum, blockchain has evolved from its initial vision, which was just one cryptocurrency throughout the world. With Ethereum, now you can go ahead and put logic inside Ethereum, and you can bring lot of applications in blockchain world. Now blockchain with these emerging technologies have answers to the challenges which were raised earlier, And with incorporation of smart contracts, the possibilities have become endless. So as you can see through this session, it is very much evident that blockchain is a tech, but and Bitcoin is merely the first mainstream manifestation of its potential. So I will end the session with this thought. Thank you very much.